Okay guys, I think we're ready to begin with another concept review. This one's going to be all about taking the derivative of exponential functions. I'm sure you know the exponential function e to the x, but of course it's not the only exponential function. We can use exponential functions in all sorts of bases, 2, 3, 5, 7. So this looks at the derivative of those and see how we come up with the rule. So let's get started. So first of all, you already know about e, and that the derivative of e is e. So we're going to try to figure out the derivative of, for example, 2 to the x or 3 to the x. And if you look at number 1, we've got, let's suppose f of x is 2 to the x. Using the definition of the derivative, we know that the derivative of anything would be 2 to the x plus h minus 2 to the x, the whole thing divided by h. So for g prime of x, we're going to use that same limit definition of the derivative to get the derivative of 3 to the x. Well, okay, there's the limit definition for the derivative of 3 to the x. The second line of the derivative for f of x, it looks like we're going to separate 2 to the x plus h into the 2 to the x times 2 to the h. So for our side, we'll do the similar thing for 3 to the x. There we go. 3 to the x times 3 to the h minus 3 to the x. Lastly, we have seen that on the f side, they are factoring out here, factoring out 2 to the x. So we'll do the same, only we're going to factor out 3 to the x. So there we go, we've factored out 3 to the x. And that brings us roughly to what they have here. Actually, it's really similar because this is 2 to the h and this is 3 to the h. 3 to the x no longer has an h in it, so when you're taking the limit, that 3 to the x can basically jump out of the limit, and we can say that the derivative is 3 to the x multiplied by this weird limit. The next thing in our story of the derivative of 3 to the 8 or 3 to the x is to look at that limit chart there and just substitute all of those numbers. That's a lot of calculator work, which you can make easier by using the table feature of your calculator. I'm just going to give you a second to do that, and then I'll go put mine over there. So go ahead and pause it here and calculate. Okay, so here is what I came up with, and as h approaches 0, we're approaching this area right here. Okay, so it looks like as h approaches 0, 2 to the h minus 1 over h is going to be some number between, what is that, 696 and 691. You can call that 693 or 694. I think I called that 694. Yeah, I did. Over here, when h approaches 0, it looks like 3 to the h minus 1 over h. That's going to be about, I don't know, 1.98, 1.99. 1.099, yeah. Okay, so those are those numbers, and as you're thinking about those, think about that we have one number that's 2 and another number that's 3. And let's think about, are there any transcendental numbers that we know or that are somewhere between 2 and 3? That might perhaps explain why one of them gives us 0.69, one of them gives us 1.09. That is a number greater than 1 and a number less than 1. Now, as they do these calculations on the next page here, you'll notice that right over here, we've got, if we tried that same limit and we used 2.5, we would get a result that's less than 1. And if we tried 2.75, we would get a result that's greater than 1. So really, a result that would give you exactly equal to 1, whatever that function is, it's going to be exactly equal to 1 for some number between 2.5 and 2.75. And of course, by now, you should know that that number is e. e being, of course, 2.718. So let's try to get this done a little bit more analytically. And the idea here is to use this process right here. If you have a to the x, okay, that is the same thing as e to the natural log of a to the x, which of course is in turn equal to e multiplied by x natural log of a. So a to the x equals e x natural log of a. All right. I don't know why I bothered. That's just written right over here. So when we get to 4, we're going to express 2 to the x in terms of e. And that gets us to, what is that? E to the natural log of 2 to the x power multiplied by x. And that's equal to e to the x natural log of 2. Well, I know how to take the derivative of e to the x. The derivative of e to the x is e to the x multiplied by the derivative of x. Or to put that another way, the derivative of e to the u is equal to e to the u multiplied by du dx. In our case, our du dx is x natural log of 2, and the derivative of x natural log of 2 is just natural log of 2. So the derivative of 2 to the x is e to the x log 2 multiplied by the natural log of 2. Of course, the natural log of 2 is a number less than 1 because 2 is less than the base e. So therefore, that gives us the limit of 2 to the h minus 1 over h. That's equal to just the natural log of 2. And I think I've written this wrong here. That should just be natural log of 2. Okay? We're going to do the same thing for 3, or for question 5, but now our base is 3. So 3 to the x, of course, that's the same thing as, let me scroll this. That's the same thing as e to the log 3 times x, or to the x power, which is e to the x log 3. Take the derivative, and you'll find something very similar. That's e to the x log 3 multiplied by the natural log of 3. Therefore, this limit right here, and I'm pretty sure I wrote it wrong again, but that limit should just be equal to the natural log of 3. Let's make those corrections and make that the natural log of 2 and the natural log of 3 over here. So that'll make this look a lot better for us. And finally, since we can't classify this function as either a polynomial nor an exponential function, it seems a strange mix of both. So now they're going to say, what about this function right here, x to the x power? Well, using what we know, the derivative of x to the x power, well, that should be the same thing as, let's write this down. Well, to start off with, x to the x is the same thing as e to the x natural log of x. So the derivative of x to the x is the same thing as the derivative of e to the u, where u is represented by x log x. And then to take the derivative of u, you have to use a product rule. So the derivative of x is 1 multiplied by natural log of x plus x times the derivative of natural log of x, which is just 1 over x. And when you simplify that out, you get du dx is 1 plus natural log of x. So when we get back to the main problem, the derivative of e to the u is e to the u multiplied by du dx. E to the u, of course, is e to the x natural log of x, and du dx is 1 plus natural log of x. So x to the x is the same thing as e to the natural log of x times x, and the derivative of such is x to the x multiplied by 1 plus natural log of x. So that solves that mystery. What is the derivative of x to the x? You can go ahead and put that in your notes and save it. And that's it for us today. Pretty nice and short one here with this concept. So I'll see you guys next time.